RHS Pre-calculus presents
Math on a plane. How to find the speed and heading of a plane affected by wind.
In aviation, north is 0 degrees, and the angle proceeds clockwise when positive. You are flying a commercial airplane at 500 miles per hour at 330 degrees, when suddenly you encounter 70 mile per hour wind blowing towards 45 degrees. What is your new direction and speed? It helps to think of the situation as a triangle, with the three sides being your original heading, the wind, and your new unknown path.
The length of a vector is the speed at which a plane or the wind is traveling. Remember, in aviation, north is 0 degrees, and the angle proceeds clockwise when positive. The plane is going at a heading of 330 degrees at 500 miles per hour. We begin by finding the angle that the wind forms when it crosses paths with the plane. The wind is blowing towards 45 degrees. This will push the plane to the right, an unknown amount represented by this line. Using the alternate interior angle theorem, we determine that this angle is 60 degrees. Therefore, angle A is 105 degrees.
Since the plane was going 500 miles per hour along its original path, we will give side AB a value of 500. The wind is blowing at 70 miles per hour, so assign line AC a value of 70. Now, we calculate the length of the new side using the law of cosines. The equation we use is a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Substituting the values we have into the equation, we get a squared equals 500 squared plus 70 squared minus 2 times 500 times 70 times the cosine of 105 degrees. When we plug this into the calculator, we get A is equal to 522.5. This means that the new speed of the plane is 522.5 miles per hour.
Now we use the law of sines. Using the law of sines, we can find the new direction that the plane is going. The law of sines is sine A over A is equal to sine B over B is equal to sine C over C. Substituting the known values, we get sine of 105 is equal to, sine of 105 over 522.5 is equal to sine C over 70. When we plug this into the calculator, we get the sine of C is equal to 0.1294. To find the angle, we have to use the inverse sine function. Therefore, the answer is 7.4 degrees. Since the wind is blowing to the right, we add this angle onto the plane's original heading of 330 degrees. The final direction of the plane is 330 degrees at 522.5 miles per hour.